The other common type of question I'd like to ask is find the coordinates of the image point. So that means basically if we have some function and this point lies on the function, the image is basically the transformed point. Now, where does that point go? We had a bit of a look at that at the beginning of this, right? Basically, it's going to be relying on the effect on x, y. So they're going to tell you these transformations, and we have to interpret them for the various coordinates. So it sort of makes sense for vertical translations and the dilations. They're pretty straightforward. Just again, being careful with horizontal because they can be a bit unexpected depending on what the effect is. So let's look at this one first. Again, maintaining our orders, so I can see that we've got negative x here, and I know that's a horizontal dilation that's reflecting it in the y-axis. So if I have the point 8 minus 12, what's happening here? We've got 8 minus 12 here, so I've got 8 across, negative 12 down. So if I reflect it in the axis, in the y-axis, then we're going to go from 8, negative 12, I'm going to go to negative 8, negative 12. That's the first thing. And then I've got a vertical dilation over here, so multiplying the whole thing by 6. And that's, again, just going to be multiplying the y-coordinate because it's a vertical effect. Multiplying this by 6, goes all the way down. So that becomes negative 8, negative 72. And last but not least, we shift up 5 units. So that's going to become negative 8, negative 67. Okay. So that's our new transformed point on this transform function. Okay. So we're going to apply a similar idea to all of these actually. So same thing over here. Let's start off with our horizontals. So remember, -1, just be careful. So I've kind of tweaked it slightly because the way I think about the horizontal translations is, again, just going back to a parabola, if you have y equals to x squared, and then you do y equals to x minus 1 all squared, where's that going to go? Well, that's actually a shift to the right, okay? So in this sense here, it's the opposite, right? So if b is negative 1, then when you put in b here as negative 1, you're going to be adding this value. So you're going to be moving 1 to the right. So that's actually what's happening here. You're going 1 to the right, so you're adding 1 to this value. So that's going to become 9, negative 12. And then we've got a vertical dilation multiplying by 3, so that becomes negative 36 for the y value. Adding 5, so it'll be negative 31. All right, so just do this bit by bit, maintaining that same order. Last but not least, so we've got this one over here. I'm going to start off with the horizontal dilation again. So this is where you do need to be careful because you can see how it's multiplied by 2, right? So a is 2 in this situation, but remember that's a scale factor of 1 on a. So that means you're actually halving the x value, right? So that's something just to be aware of. So we go from 8, negative 12, halving the x value to 4, negative 12. Now we've got a vertical dilation here. We're reflecting in the x-axis. So that's going to become now, oh, we're going the other way actually. So reflecting the x-axis, that's going to become positive 12. And then we take away 7. So 4, 5 is our transformed point. And here's our last type of question, describing transformation. So here we need to be comfortable with the terminology and also be comfortable with the expressions that we look at, right? Maintain that same order, generally is what they'll ask. So let's try this. So we are, first of all, thinking, how did they create 4x cubed? So we're starting with yx cubed here. Let's shift here, big 3 there. All right. So the first thing we need to do is, we actually need to do that vertical dilation, multiplying by 4. So vertical dilation of 4. And then we are shifting down 1 unit. So vertical translation, 1 unit down. Okay, next one. So same idea, what's the first thing that happens? Again, just following this order. So we've got a horizontal translation. So if it's negative 1, again, we're shifting right now. Horizontal translation of 1 unit to the right. And vertical translation is plus 7 on the outside, 7 units up. Whew. Okay, now this is where it gets tricky because sometimes you get something that looks like this. And if it's not just a single value of x, then it's hard to see what's exactly going on. So what I'm going to do is rewrite this as this. So how is this different? Sorry, that should be like that. There we go. So I factorized out the 2 here, and what that allows me to do is actually, now that I'm thinking about this, what I need to do is be able to recognize that there is a horizontal dilation that's happening here. The horizontal dilation is an A value of 2, okay, because I can't really see that when it's in this form, but now I can see it. It's a horizontal dilation. Sorry, I don't know if I said scale factor. It's been multiplied by 2, but that's a scale factor of, remember, 1 on A, right? So it should be half. And then it's a horizontal translation of, again, with the negative, so that's 2 units to the right. And then a vertical dilation of 6. And shifting up 5 units. All right, last one. That's a really badly drawn 10. Let's fix that up. So last one here, I've got 2 outside of 3x plus 9 all cubed minus 10. Same idea, I'm going to factorize out this 3 that I can see. So x plus 3, and then that's all cubed minus 10. So same idea, what's the first thing that's happening? It's a horizontal dilation. Horizontal dilation, scale factor 1 on 3 now, because, 1 on A, whatever the A value is. Then we're shifting, this time we've got a positive value here, so we're actually shifting to the left. 3 units. And then, same as always, what's the number out here? That's our K value, so that's a vertical dilation of 2. And last but not least, shifting down 10 units. So those are kind of the main types of questions for transformations. They can also ask you to sketch things as well, so be prepared for that. But that's just like a bit of a whirlwind tour through the types of questions they can ask you.